Hello everyone, I hope you've been having a good time observing the night sky. I know I have. I've been taking some data lately. We've had some good nights. Good nights clear at the beginning of September. This is Professor Jeff Wilkerson with what to look for in the night sky, this time for the week of September 13th, 2021. And so let's talk a little bit about what's out there just after dark right now. As it's getting dark, I've been watching Cassiopeia rise into the sky in the sort of northeast. As I look northeast as it gets dark, the stars that I see just hanging above the horizon are this sort of W of Cassiopeia. W with the left-hand side lying down a little bit weakly like that, but it looks a little bit like a W. If you want to identify one of the stars in there, they're all pretty bright stars, the ones that we've marked right here anyway. There are other stars, of course. That's Calf. Good star to start to try to recognize. If you're as far north as I am here in Iowa in the United States, then you see this is far enough north that it's circumpolar. It's up all the time. You can see this star regularly, so pretty much any time. But now it's climbing high into the sky as evening approaches. Below Cassiopeia is Perseus. So Perseus is down here, and so one way to identify Perseus, this is the brightest star in Perseus, is Myrfak. And this brightest star in Perseus is going to be, if you just follow that line downward and drop toward the horizon right now, as you go out after dark, the brightest star you come to headed that direction is the bright star, the alpha star of Perseus, Myrfak. Now, you might need to wait a little bit for this to get higher into the sky. Right as it's getting dark for me, 8 o'clock, I can see Cassiopeia rising into the sky pretty easily. Might want to wait until 9 o'clock, maybe even 9:30. That's, again, my local time. Your time might vary a little bit, but you need to wait a little bit more past dark to get so Perseus is relatively easy to see. What we've marked here are the sort of the brightest stars in Perseus, some of them, that I like to think of as sort of the body of Perseus is in sort of the legs down this direction. You might see these stars in Perseus. There are fainter stars that curl on around here, and so I see that as a J. And it is, as I tell students every year, absolutely. It is just, I'm sure, a random coincidence that I see my initials in the sky, JW, right there. But that's what you see climbing over the horizon right now. And so these stars go out, try to identify them. Pretty easy to locate, I think. Nothing's ever terribly easy to locate, but this is your chance, since they're so close to the horizon, to get a good read on them here. Now, this star is what we want to talk about most, and I think we've talked about it before, but we'll talk about it again because you might have forgotten one of the many videos that I've posted out there. This is Algol, the beta star in Perseus. And Algol is an eclipsing binary star. And eclipsing binary stars are great. Okay, I'm just going to go flat out. I'm just going to tell you they're great. And so you can learn the stars in this region, but I'm going to set you up on another observing project like I like to do sometimes. So this I would like for you to go out, I think, have fun if you can, and observe Algol on the 15th of this week, September 15th, if you're in the United States. If you're not in the United States, the timing probably doesn't work very well for you to do this. But this is an eclipsing binary star, which means you have two stars in orbit around each other such that one star passes in front of the other star. Two stars, one star, and so you block some of the light, and it gets a lot fainter. And so that's what the trick is with eclipsing binary stars. Now, Algol does this. It reaches a minimum of light about every 2.9 days. So about every 3 days. Think about that. That's an orbital period for this system is about 3 days. When you think, 88 days is the orbital period of Mercury, and we think of that being fast around the sun. So these stars are pretty close to each other. And typically eclipsing binary stars are that we see, not always, but typically. And the reason for that is just pure geometry, right? If we're out here looking at an eclipsing binary star, if the orbit has to be pretty much in the plane of our vision. If the orbit's tilted up like this at all, those stars won't eclipse, right? And the further away the stars get, the further away the stars get from one another, the smaller that angle gets to be, such that you don't get to be an eclipse. And so they really have to be aligned. If these stars are far enough apart to have an orbital period that's months, then they have to be really locked right onto our line of sight for us to see them eclipse. If they're tipped at all, this star won't block this star when it orbits around this. Hopefully you can see that geometry and look at that. So it's not uncommon. In the research project we do, we have discovered there are about 5 eclipsing binary star systems in our field of view that we work with, and most of them are in the cluster that we study, which makes them particularly interesting to us. One of them was previously known, so we've just been measuring one eclipsing binary star. 4 of them we discovered ourselves here, and we've been timing for years to see how the timing and the depth changes over time, if it does, with these eclipsing binary stars. But what makes Algol great is this is a relatively bright star. This is a star that's 2nd or 3rd magnitude, so you can see it. You can walk outside and say, I see Algol, there it is. So you go over here, you drop down from the W of Cassiopeia to Mirfac, and then over to the boom, lower right triangles. We've been doing right triangles the last few weeks. There's another one, more or less, right triangle, and there's Algol, okay? And you see it with your naked eye. You don't need a telescope, you don't need binoculars. There it is. And the other thing that's great about it is it changes brightness a lot. So if these 2 stars that are passing in front of you, if they're equal brightness, then about the maximum depth you can get is you get about half as bright, right? But if one of these stars is a lot fainter than the other star, and the faint one blocks the bright one, you can get a lot more than a factor of 2 in brightness change, right? You see that? Faint star, bright star, the sum is mostly the bright star, and you block the bright star, and now it's mostly the faint star. And you see, and this, when Algol is in eclipse, when Algol's at its minimum, it's fainter by more than a factor of 3 than when it's at its brightest. So it's more than a factor of 3, and what's great about this week, so again, every 2.9 days it does this, so we can pick a lot of times to do this, but for those of us in the United States this week, on the 15th, so we're talking about September 15th, you go outside just after dark, and you will see it very near minimum light. And so if you made a graph of sort of how bright it is as a function of time, you'll see it down here, and it's going to come up very, very sharply and get brighter and brighter and brighter. So these stars that you look at, the star right here to its left and the star right here to its right, rhymes with bright anyway, the star right to its right over here, Algol, when you go out just after dark on the 15th, Algol will be fainter than those 2 stars. Take a look at it. If you've got nothing to do that night and you could spend the next 3 or 4 or 5 hours, it'll take about 4 or 5 hours for it to get up here to maximum brightness, but it'll be 3.5 times brighter, 3.3 times brighter when it gets up here to maximum brightness. And so, time, not titanium, and so you can track this, and it's a really interesting thing to see. In live time, you can see that star getting brighter. By the time it ends, it'll be as bright as these stars, or maybe brighter than those stars. So it's gonna start quite a bit fainter and get up relative to relative brightness compared to those stars. And you can pick other stars around too to compare its brightness to, and sort of keep track of it and map it as it gets brighter. And it's a fun project to do. And what makes this one great is it's at minimum just after dark, or right just before dark. And so when you go outside, you're seeing it very close to minimum. And over the next few hours, you have a chance to watch it really change. And it's the earliest few hours of darkness in the evening. So this is a great time to go out if it's clear on the 15th. So if it's clear on the 15th, get out and do that. If it's not clear on the 15th, you can find online, there's many online calculators for when the next minimum will be, and you can find out when the next minimum is to try it. But if nothing else, you can identify the stars of Cassiopeia and Perseus and start to get to know this region of the sky. So this is a great region of the sky we'll probably return to. I'm sure we've talked about it before. We'll return to it again a couple more times this fall. Beautiful marker to fall. Tells us that we've made it into the fall season when we see these climbing into the evening sky. Good luck with this. Enjoy learning the stars. Enjoy a nice observing project to try out, and let me know how you did. So clear skies ahead. I hope you have a good week, and we'll have something new and fun for you next week.